So a lot of times when I ask the students to read a math book, they just look at it and say they don't get it. So I've asked you like specific questions to see if you can kind of translate the book to kind of what I know what you're supposed to be understanding when you read those words. So I'm trying to focus your energy into these questions. And you can talk about it. Maybe somebody next to you is really good at reading.
Are we allowed to highlight things?
Yes, that's yours. You can do whatever you want on there. There will be a Bowler quiz on chapter 2. I don't even know if there was Bowler quiz. Alright, I feel like I should just get into this. I do hear someone else coming. Oh yeah, so what is the root of an equation? The solution, yeah. So roots is like a synonym for solution. And I'm going to go even further, and I'm going to add to that. Solutions are x-intercepts. So roots, solutions, and x-intercepts, they're all kind of synonyms. There's little tiny details in the definitions where we can get nitpicky, but for your purposes, roots equals x-intercepts equals solution. So all of those things are the same thing. So that's just like some vocab for you. So if you're asked to find roots, no, it's asking you to solve. So chapter 3, we're transitioning into solving. Chapter 2, we were writing equations. We used those forms and we plugged in and we wrote equations. We found a vertex. Chapter 3 is all about solving. We're actually finding what x equals. Okay, next, what 3 methods can be used to solve? And actually, there's more than 3. We're going to solve quadratic equations in 5 ways. That's why this chapter is so thick. We spend so long talking about how to solve equations. But what three methods does it show right there on page 181? Graph, square root, and factors. That's all covered in this one section. We've already covered how to graph, so that's a review. It's just that today we're going to graph with the goal of finding the x-intercepts. I think I've already really kind of emphasized this. Where are the roots of a quadratic equation on a graph? They're on the x-axis. They're the x-intercepts. When you read example 1, does it explain how to graph? No, it just pops the graph up. You have to use chapter 2.1. No, I think it's 2.2. Or the handout that I gave you. Okay? So from this point forward, your book isn't going to explain how to make a graph. It's already been taught, so it's assumed that you know how to make a graph. Okay, so let's go ahead and review that. Go to page 189, and this is the first problem in your assignment. This is not at all today's lesson. This is just a preview of the lesson, but let's just jam it out. So let's make a graph, and then really the new things for you today is number 2, we're going to square root. So I'm going to run through this graph pretty quickly so you guys get into I'm gonna go through it very quickly. So I gave you guys some time to start. I'm gonna jam it out now. I'm going to page 29 and doing number 1. What? It's not done, is it? Oh, I went ahead and made a big note for myself. Oh, solve by graphing, that means find x-intercept. So we're going to graph x squared plus 3x plus 2. I really thought that mine looked like yours. It really doesn't. I mean, I keep going. There it is. How do we make a graph? I can't remember. It's weird how it says 0, not y, but I'm not going to overthink it. I'm just going to label A, B, and C. And then I'm going to do the most important part, negative b over 2a. Now I'm going to be annoyed because the whole thing's going to have a fraction. I know for the test I said you guys are, for the assignments, I said you can make that a decimal, but let's just do this in fraction form. I mean, if you want, you don't have to. You do? Okay. All right, you do what you feel, but I'm going to go ahead and go this way. Put it in your calculator. Put that in your calculator. It's snowing outside. Have you seen the weather? I'm in a movie right now. I don't know where you are. I'm actually sweating a little bit. No, I want to. It's on my list. Things to do. Oh, I heard it was really good. It's not that good? It's okay, no judgment. We all have our opinions. No, move on. Move on. It's okay. It's okay. I might still enjoy it. You know what? That all sounds very opinionated, but what we know for sure is that y is negative 1/4. That's the good thing about math. We have one answer we can all agree upon. The numbers said it. Okay. So now I know my vertex, and yeah, go ahead. If you want to make it a decimal, that's fine. It's -3/2 and -1/4. And you can use your calculator. I did it all by hand. For anybody wanting the upgrade, you can do it like that if you want. Okay. So we have a dashed line at 1.5. Where'd it go? Moving back. And then we have a whole dot at a weird area, -0.25. Okay, now we just got to make a quick table. So I guess to go to the left, I'll go -2 and -3, and to go to the right, I'll go -1, 0. And I like that because I can put the 0 and intercept this 2. So that means we just have to plug in one number. So with your calculator, plug in either -2 or -1. And I'm going to do it by hand. I plugged it in and I got a 0 out. That's a root. That's an intercept. That's what I was looking for. Mission accomplished. So that's actually what we were looking for. We were trying to find x-intercepts and we just found one. That's so good. That is a good feeling. I'm gonna go ahead and do this one too. It's gonna work out nicely. So. We get another root. So we found our 2 answers. Correct. -2, -1. So when I plot this, here's the 2 and the 2. And the other ones are just right there. So this point and this point are the solutions. I did all of that work. Gosh, it's a lot of work to just figure out that the answers are -2 and -1. Okay. So you're graphing with a purpose, and the purpose is identifying the roots or the x-intercepts. So while the graph is the work, the answer is actually what's in the box. The x-intercepts. I found them in the table. And so sometimes, like we got like here, vertex is really close to the x-axis, but like sometimes your parabola is like really far away. Like let's say this was 10. And so if this was it, I have to keep finding points until you find the x-intercept. So you have to keep graphing until you get to the x-axis. Because what you're looking for is where it hits the x-axis. So sometimes if it's far away, you just got to keep going. Okay? Now, really, truly, that's a review because we've already been through the steps of graphing. So now we're going to move on to solving by square rooting. Here we go. It's page 183. So now move on to page 183. Page 183 is all about, can we please just find the roots without making a graph? Can we please do that? Yes, you can. You can find roots without making a graph. There's other ways to do it. Making a graph takes a long time. It's a lot of work. So let's do it without graphing. So, yes, all of the limitations will come into play for any parabola that actually never crosses the axis. No solution. Okay, so let's look at square rooting. They do have a great example here, but they do skip some work that I would like to show. For instance, how does it go, letter A, how did they move from the number 49 to the number 80? How did that happen? It states it here, but if for students who don't read those red steps, they look at this and they say, I have no idea what's happening there. Let's show the work. They added 31 to both sides, so it gets to 80. And then how did it go from 80 to 20? Oh, okay, but they didn't show like how we show it. We show the division on both sides. Okay. All right, so they all of that is like isolate x squared. That's what those steps are, and it looks different every time. But they moved the 31, they moved the 4, and they got here to x squared equals 20. Once you get to the x squared part, you take the square root of both sides. And a square root cancels out the exponent. And that's how they go from x squared to just x. So I want to make a big note in this margin. As soon as you square root, use plus or minus. Because you don't know if it's a positive or a negative x. You have to show that with a plus or minus. Like for a more basic equation, this one, like what could x equal if x squared is 25? X is 5, right? Because 5 squared is 25, that tracks. X could also be negative 5. Because a negative times a negative comes out positive. So when you square root, you have to acknowledge that there's two things that could have happened, and you acknowledge that with a plus or minus sign. Okay? So if you don't use the plus or minus, you're showing half the answer. So you get 50% credit. What's the square root of 20? I'm wondering what your calculator will tell you. Actually, I mean, we can estimate it. Like the square root of 16 is 4. The square root
It actually gives you 2 and then the 5.
So, if you're working with the class calculator, simplify radicals for you. For the classes next year, college algebra, honors pre-calculus, the teacher won't let you use that calculator. You'll have to know how to do that. Okay. In ACE Math, the ACE Math exam doesn't care how you get to the answer. So it's a little weird, that one. Okay. So anyway, you have to know how your calculator is showing 2 square root 5. What it's looking for is anything that 20 divides by that does square root. So that's called a perfect square factor. So they square root the 4, and that's where the 2 comes from out front. Let's make a big note, more or less no decimals. For your final answer, unless it starts as a decimal, no decimal answers. This is called simplest radical form. Okay, read letter B. I have a toolbar here in your way, but it's minus is 9, subtracts 9, and then it divides by 3, and it's a negative 3. It says that you can't square root a negative, so that's no real solution. Is everybody good? All of these things are about to disappear, is everybody good? There we go. Okay, that's a really good example for the more complicated ones, but let's just go to your assignment right now and try some of these. We're still on the same page. We already did number 1. We have to do number 2 and 11 through 16. So I'm going to do number 12 with you, and then I'll do 16 with you. Okay? So everybody go ahead and do number 12. Okay, number 12 is a problem you've done before. A is plus or minus 9. Please don't just write 9. Actually, I'm going to add 5 first. Okay, and then divide. Yes, don't distribute. And don't square. Alright, I'm jumping to 16. So I'm trying to isolate the parentheses now. So I'm adding 5 over. And then a lot of people want to distribute this to it. Distribute. Don't. You can't do that. Divide on both sides, and you're just going to have to work with a fraction. And now we'll square it. Just keep it a fraction. when you square root, the parentheses go away. And then you want a minus 2. And that's how your answer is going to look for today. So we're gonna leave it.
Yeah. Look at real, it's so weird. Of course you can, Libby.
So when you look at number 13, it's a little bit different. Because you can actually square root 25 and turn it into 5. So when you add 6 to both sides, you have to make it into 2 different equations. You can do 6 plus 5 or 6 minus 5. And it gives you 2 completely different numbers. It's a little bit like that, yeah. If you think about, if you put 11 in there, if you plug it in and check it, it works. If you need me to, it'll be in the media center. The media center.
Yeah, $40 for home.
That's what I just asked her. I was like, you want to pay $40 for me to go?
Let's go.